All right, so solving by taking square roots. So most people think that it's pretty easy. However, there's actually a little bit more room for error than most think. I've actually seen a lot of students, like, they're like, oh, this is so easy. And then when they do it, it's like, what did you just do? All right. So, thing about solving by taking a square root. First off, you can only do it, if my pen would write, you can only do it if there is no bx value. Yes. Yeah. So, instead of ax squared plus bx plus c equal to 0, it'll more so look like ax squared plus c equal to 0. So you can only take a square root if you don't have that b value. All right, that's the only way you can solve by taking a square root. Otherwise, you have to pick another method. All right, now remember, solving any equations by using a square root, we use order of operations, specifically PEMDAS. So y'all should definitely know what PEMDAS is. Well, what I tell students is, because a lot of times when you throw in the quadratic, it becomes hard to figure out what you do next or when you take the square root. Probably the most difficult thing that I see students do is they don't know when to take the square root to get rid of the square. All right. And more often than not, they take it in the wrong spot. So what I tell them to do is think about SADMEP. What do you guys think SADMEP is? The opposite of PEMDAS. So whenever you solve, you think about SADMEP, which is the backwards PEMDAS. So you start by taking care of your addition subtraction, then your multiplication division, then your exponent, and then if there is parentheses, anything with parentheses. All right. So that's what should be going through your brain anytime you solve a quadratic, because that will help you figure out when you should take the square root. I know you guys can do all the other inverse operations, but again, the hardest part about solving a quadratic by taking a square root is figuring out when to take the square root. All right. So let's look at these three problems. Very similar. This first one's just linear. So just review for a two-step. What do I do first? Add the 1. I get 2x is equal to 32. Then I do what? Divide by 2. X is equal to 16. So that one wasn't even quadratic. It was just kind of a warm-up to get you thinking inverse operations. This one is quadratic. All right. So think SADMEP. What do I have to take care of first? The addition subtraction, so the minus 1. So I'm going to add the 1 to both sides. I get 2x squared is equal to 32. Now, right here is where most people screw up. Right here, a lot of people like to go ahead and take the square root. You cannot do that. Why? Because there's a number being multiplied to it. And what comes first in SADMEP? Multiplication, not exponent. So we got to take care of that 2 first. So what do I do next? Divide by 2. So x squared is equal to 16. Now I can do the square root. So I'm going to take the square root of both sides. So x is equal to what? Not just 4, plus minus 4. Remember, whenever you solve and you take a square root, you've got to put the plus minus. It's really only needed when you're doing solving. But if you take a square root at any point when you're solving, you've got to put the plus minus. Now, this next one is one where you really want to use SADMEP. So, what do I handle first? Add the 1. So 2 times x minus 3 squared is equal to 32. Right. Why can I not distribute this 2? Because it's being squared. All right, that square prevents us from distributing the 2 in the parentheses. So instead, to get rid of it because it's being multiplied, we just divide it out. So I have x minus 3 squared is equal to 16. Right, so why would I square root both sides instead of add 3? Because the x minus 3 is in parentheses, and exponents come before parentheses. So I'm going to take a square root of both sides. So x minus 3 is equal to what? Plus minus 4. And the last thing I'm going to do is add the 3. So x is equal to plus or minus 4 plus 3. Now, I'm not quite done yet, because what can I do now to get 2 definitive answers? Nope.
You separate it to
There you go. You separate the plus minus. So, in other words, we're going to have positive 4 plus 3 and negative 4 plus 3. So you should have 2 different answers. So the last thing you should do, especially if you have 2 rational numbers, separate that plus minus, get the 2 answers. So what's 4 plus 3? Negative 4 plus 3? So x is equal to the set of negative 1 and 7. Now, that was just to kind of get your brain into the habit of SADMEP. So again, if you don't know what to do next, think SADMEP. Take care of everything in PEMDAS but backwards. All right? Because again, the biggest struggle that students have with this is that they take the square root at the wrong time. Specifically when they still got something being multiplied to it. That's usually the most common mistake I see. All right? Now, before we get into anything deeper, let's review some radical stuff because we will be seeing this a lot today. So we did touch on this yesterday. All right, but to simplify the square root of 72, what do I do first? I find 2 factors of 72, specifically when, what? The largest perfect square factor. So what is the largest perfect square that can go into 72? 36, and 36 times 2 is 72. So I can rewrite this as the square root of 36 times 2. So I remember I can separate that into the square root of 36 times the square root of 2. So what does it simplify down to? So 6 square root 2. All right. Now, that's simplifying. Next, 1 over the square root of 2. What's wrong with this picture? Square root of 2 is in the denominator. We don't like that. So what do I have to do? Right, we got to multiply the top and the bottom by the radical in the denominator. What's that called? Rationalizing the denominator. Good. So what's 1 times the square root of 2? Square root of 2. What's the square root of 2 times the square root of 2? 2. You could also say it's the square root of 4, but it would still simplify down to 2. Can I simplify any more? You could, but honestly, I would just leave it like that. All right, this one. So we talked about this yesterday. We have a fraction under a radical which we don't technically like. How do I take care of it?
both sides. Top and bottom.
So you can split apart the radical itself. So I can rewrite this as the square root of 144 over the square root of 9, which they're both perfect squares, so that works out. What's the square root of 144? Square root of 9. What's 12 divided by 3? 4. So that's typically what you want to do if you have a fraction under the radical. Rewrite it as 2 separate radicals, one in the numerator, one in the denominator. Simplify where you can, whether it's taking that square root or rationalizing. Because the next one, what we got here? How would I set this up? You could. I'm going to leave it as 8 over 20 for right now, though. You'll see why in just a second. Make the square root. So square root of 8 over square root of 20. I would simplify these radicals first. How do I simplify square root of 8? 4 and 2. So this is equal to square root of 4 times the square root of 2. I'm not going to simplify it any further yet. You'll see why. Over. What about 20? 4 and 5. So I have square root of 4 times the square root of 5. So before I even move forward, do I even need to bother simplifying square root 4? No. What happens? They cancel. Now, you could have also simplified this fraction down to 2/5 as well and done it that way. You would have gotten the exact same thing. It's, it's to each their own type thing. Right. You still have to rationalize the denominator, though. So what's the square root of 2 times the square root of 5? Square root of 10. What's the square root of 5 times the square root of 5? 5. Is there anywhere else I can simplify? Does 10 have any perfect square factors in it? 2 is definitely not a perfect square. Nope. So we're done. So when it comes to these, it doesn't really matter what you do first. You could simplify the inside first. You could separate it, then simplify. It doesn't really matter. You're still going to be doing kind of the same combination of steps. They just might be in a different order. All right. So we did that just as a quick review because you will see it again when we get into solving. So steps for solving by a square root. It's pretty straightforward. You isolate the x squared or the binomial squared, where a is any rational number. You take a square root to remove the exponents. And you should have two possible solutions. So remember the negative version and the positive version. So remember that's where that plus minus comes in to play. So that's where the plus minus comes from. So let's do some stupidly easy ones. Let's look at example 1. What's the only thing I gotta do to solve? Square root both sides. So x is equal to what? Plus minus 10. Don't just give me 10. I need plus minus in front of it. Because is it not true that 10 squared and negative 10 squared are both 100? Yes. And we don't know which one they're talking about. Plus, most quadrilaterals, oh Lord, not quadrilaterals, doing that math 3, quadratics have two answers anyway. So that's kind of, keeping it straight. What about this one? Square root 7. If it would. Yep. So x is equal to plus or minus the square root of 7. So, because technically the square root of 7 is a number. So you need the positive version of it and the negative version. What about this one? So x is equal to plus or minus the square root of 20. However, what can I do with the 20? You can simplify it. So what are the two factors where one's a perfect square? 4 and 5. So x would be equal to plus or minus what? 2 square root 5. Square root of 4 is 2, and the 5 stays under the square root. So you guys know how to simplify radicals now. So I want your answers as a simplified radical if it can. All right. So if your radical can simplify, simplify it. I will no longer accept rounded answers. All right, so you should be giving me exact, and these are exact. All right, move on to slightly harder ones, but not really. Example 4, what do I do first? 5 by 6. Do not take the square root first. Sad MEP, multiplication comes before exponent. So I get x squared is equal to 8. Then what do? Square root both sides. X is equal to plus or minus the square root of 8. Can 8 simplify? Yep. How do I break it apart? 4 and 2. So x is equal to plus or minus what?
2 square root 2.
2 square root 2. What about this one?
Take the square root.
Oh, definitely not. Yep. I don't care if the coefficient is a perfect square. Do not take the square root first. Just don't do it because you'll get yourself in a bad habit and then you'll screw yourself over on a later problem. Just trust me. So, you have x squared is equal to 121 over 4. Take the square root. X is equal to plus or minus square root of 121 over 4. Now, we know how to simplify that, right? What do? Separate them. And yes, it would be plus or minus 11 over 2. Because the square root of 121 is 11. The square root of 4 is 2. So again, I don't care if the coefficients being multiplied to that x squared is a perfect square. Don't take the square root until you divide it out. I can promise you it will screw you over. All right, because you'll get yourself in the bad habit, and then every time you see like 2x squared, you'll take a square root and be like, well, what do I do with the square root of 2? Don't do it. All right. Last one. What do? Divide by 9. X squared is equal to what? So square root both sides. X is equal to what? Plus or minus the square root of 6. Can I simplify that further? Nope. No perfect square factors. All right. Slightly harder ones. Let's look at 8. What do I do first? Add 20 to both sides. So I get 3x squared is equal to 20. Divide by 3. So guys, don't put that in your calculator and get a decimal. Just leave it as a fraction if it doesn't go in evenly. Then what do? Take the square root. So x is equal to plus or minus the square root of 20 over 3. How do I simplify? Not yet. Right. You can't start multiplying square roots of stuff until you break it apart. Now we can rationalize by multiplying the square root of 3 over the square root of 3 to it. So what's the square root of 20 times the square root of 3? What is square root of 3 times square root of 3?
Square root of 9.
Square root of 9 or just 3. Either way. All right. Now, I could pretty much break down 60 if I wanted to. What's my highest perfect square that goes into 60? 4. And 4 times what's 60? 15. So this would be x is equal to plus or minus what? Good. Can I simplify that any further? You could, but I wouldn't. I would just leave it just like that. All right. Do I need to do another one like that, or are you good? All right. Now let's look at when we have binomial squared. So again, this is where SADMEP will help you. So look at 10. So, do I subtract the 1 first, or do I take the square root first? Why? Right, parentheses come after exponents in SADMAP. So we square root both sides. So I get x plus 1 is equal to plus or minus, what, 4. Don't forget the plus or minus, because you should not be getting one answer for a quadratic. Unless, the discriminant was 0, then yeah, you get one answer. But more often than not, you are definitely going to get 2. It's very rare that you get 1. So what's my last step? So x is equal to plus or minus 4 minus 1, which, just like Riley said, will separate the plus minus to be positive 4 minus 1, negative 4 minus 1. So x is equal to the set of what?
3 and -5.
Negative 5, which is negative 4 minus 1, and 3, which is 4 minus 1.
Does it matter the quadratic?
It really doesn't. I just kind of default to numerical. I wouldn't count it wrong, though. As long as both those numbers are in that set, doesn't really matter. Like me personally, I just default to numerical. All right, now, example 11. Similar, but it's going to look a little different. So, what do I do first? Take that square root. That goes away. I get x minus 3 is equal to plus or minus the square root of 12. Now, before you move the 3, I recommend just going ahead and simplifying, because we know square root of 12 ain't going to be pretty. All right, so how do I simplify the square root of 12? 4 and 3, which is, in fact, plus or minus 2 square root 3, still equal to x minus 3. What do I do next? Add 3 to both sides. Now, you cannot add to the 2, because the 2 is being multiplied. All right, so x is equal to plus or minus 2 square root 3, because that's a number, plus 3. Remember, adding radicals is like adding like terms. Is 2 square root 3 and 3 like terms? No. So that's why we can't add the 3 to the 2. So we can literally leave our answer just like this. However, I would rearrange so that the plus or minus is after the 3, just so it looks a little bit more concise. So x is equal to 3 plus or minus 2 square root 3. And I would leave that answer. Because what type of answer would that be? What type of number? Definitely irrational. It is real, but it's irrational. All right, and we want an exact irrational, not rounded. And remember, there is technically 2 answers in here. So we have 3 plus 2 square root 3 and 3 minus 2 square root 3. They're not quite the positive and negative of the same number. They're actually 2 very different numbers. But just remember that even though it looks like we only have 1 answer, there is actually 2 there because of the plus minus. Any questions? Okay, the last part of this section. Now, we have a b value. So right now we can't solve by taking a square root. However, what do you notice about the left side? It's a perfect square what? Trinomial. It is a perfect square trinomial because it's a squared plus or minus 2ab plus b squared. So we can actually factor this to make it look like what we've been doing. All right. So who remembers how to factor a perfect square trinomial without using big X? What's the trick that I've told you guys?
You square root the first one and the last one.
Mm-hmm. So you square root the first, square root the last. Take the sign of the second. And that's your answer. So that's why I wrote it up here. All right. So what's the square root of x? X. I don't know why I was going to write a. What's the sign? And then what's the square root of 16? 4. And since we're simplifying, we don't have to worry about plus minus. Yep, equals 1. So be careful because sometimes, make sure you check, because sometimes if the if the left side doesn't look like it's factored, you don't even have to really complete the square yet. You just got to check to see if it's a perfect square trinomial first. Always check that first if you're solving by completing the square. Check to see if it's a perfect square trinomial first, because that will save you a whole lot of time. So how do I solve? Square root both sides. So sliding the 1 over is more so for converting to vertex form, but we're solving. So that's kind of the difference between the two. So I have x minus 4 is equal to what? Plus or minus 1. Square root of 1 is just 1. Then I add the 4. X is equal to plus or minus 1 plus 4. Aren't those two rational numbers? Yep. So I can split them apart and get two answers. So I have 1 plus 4, negative 1 plus 4. So x is equal to what? 3 and 5. 1 plus 4 is 5. Negative 1 plus 4 is 3. So there are my two answers. Do I need to do another one? Are you guys good with that one? All right. So that is solving by taking a square root. Now, sometimes we have b values and it's not factorable. Could be, but we also just need to learn how to solve by completing the square. So similar to solving by taking a square root, we just have to turn it into something that we can take a square root of. So when you start with ax squared plus bx plus c. And we know that we can't take a square root if we have a bx value. So we have to manipulate it so that the bx goes away. All right. So we talked about these steps before. So first off, make sure that your leading coefficient is equal to 1. If it's not, factor out the leading coefficient. And you want it to be x squared plus bx is equal to c. So in other words, move the c to the other side, whether that's adding or subtracting, whatever. Make sure it's inverse operations. Then we find b over 2 squared. That's the value that we have to complete the square root. You guys remember when we were doing like the algebra tiles and actually making physical squares? That's what we're finding. We're finding how many more of those tiles we have to use to complete that square. And then you got to make sure you add that number to both sides. Then you factor and solve. All right. So let's try this. So how can I rewrite this equation so that my constant term is on the right side? Just add 16 to both sides. So I have x squared plus 6x, I'm going to draw a blank so I know something has to go there, is equal to 16. And again, I'm going to draw a blank because something has to go there. Now, they want us to find the value of half the linear coefficient and square it, add to both sides. So in other words, that's fancy for find b over 2 squared. What's my b value? 6. So 6 divided by 2 all squared. So that's 3 squared, which is 9. So I'm going to add 9 to both sides. That's why I put those blanks there, so I know I got to do it to both sides. So again, you don't have to necessarily draw the blanks. I just highly recommend it because it's a good reminder for yourself that stuff has to go there. Yes?
you don't flip the sign when you add 9 to both sides. It's just
Right. You don't flip the signs, mainly because technically the 9, we're almost pulling it out of thin air. All right. So mathematically speaking, you can do whatever the heck you want to an equation. You can multiply anything you want to it. You can divide anything you want to it at any point in time, as long as you do it to both sides. So we can add anything we want to that at any time, as long as we do it to both sides, because we're keeping it balanced. Because that's what an equation is. It's balanced. Yes, ma'am. Yeah. So if I simplify it a little bit, I have x squared plus 6x plus 9 is equal to 25. And now I need to factor the left-hand side. So how do I factor that perfect square trinomial? Well, we're going to leave the 25 alone for right now. So square root the first, square root the last, separate them by the sign of the second. So it'll be x plus 3 squared is equal to 25. I want to rewrite that over here. Now we got one that we've, kind of know how to do already. So how do I solve? Square root of both sides. So this is where it differs from the vertex form completing the square. Because with vertex form, we would subtract the 25 back over. There's our vertex form. But this case, since we're solving, we're trying to get the x by itself. So I get x plus 3 is equal to what? Plus minus 5. Get in your head. Plus, minus, plus, minus, plus, minus. So minus 3 to both sides. X equals plus or minus 5 minus 3. Separate the 2. I have 5 minus 3, negative 5 minus 3. So yeah, my two answers are negative 8 and 2. Huh? Oh yeah, 100%. In fact, the reason that we're learning how to solve by completing the square, because I'll be perfectly honest, I hate solving by completing the square because it starts getting more complicated when you throw in A values that are not 1, and you throw in odd B values. All right, because you can technically solve by completing the square for any quadratic, but it gets ugly at some point.
Like 1 or whatever, like 1x for the b value on both sides.
Because you're trying to get the x on one side, so we'll just end up undoing what you already did. But the reason that we're learning how to complete the square is when tomorrow, when we talk about quadratic formula, we're actually going to derive it using completing the square. All right. So I'm not just going to tell you what the quadratic formula is. I'm going to show you where it comes from. All right. But to do that, we have to know how to solve by completing the square. All right. Let's try a couple more. So let's do... Let's do A. All right. So we're taking all the steps that they broke apart in the original problem and putting it all together. So what's my first step? Subtracting the 9. I get x squared minus 10x space is equal to negative 9 space. Then I find my b over 2 squared. What's my b value? Not just 10. Negative 10 divided by 2. That's negative 5 squared, which is what? So I'm going to add 25 to both sides. If I want to clean it up a little bit, I got x squared minus 10x plus 25 is equal to 16. Now I can factor that perfect square trinomial. So square root the first, sine of the second, square root the last. Make sure you put it in the bubble squared. So what is it factored? X minus 5 squared equal to 16. Now, guys, let's say it was on the test and you forgot how to do the shortcut for factoring a perfect square trinomial. You can always still do big X. Just make sure that you rewrite those two factors as itself squared, because you'll get the same two factors. Okay, we're pretty much done with notes anyway, just more of this. Okay. And there's a delta math. Now, what's my next step? Square root of both sides. That goes away. X minus 5 is equal to plus or minus 4. Add 5. X is equal to plus or minus 4 plus 5. And break them apart. So 4 plus 5, negative 4 plus 5. So X is equal to 1 and 9. So boys, we are pretty much done with notes. We're just going to do like 1 or 2 more problems. More of the same. You do have a delta math.
We just feel like people.
Nope.
But I'd rather have people who were.
I don't care. I don't care.
So we have like
Are you
the
gonna
week
give
the
us
lockdown.
homework?
Whatever.
Are you gonna give us homework over spring break?
Who knows?
You would do it to us, right? If you do, is it gonna be like
It wouldn't be like a packet. Like
oh?
it depends on where. It depends on where we are, like unit wise. Like you may just.
It's gonna be
So not for unit 4, but we are starting unit 5 before spring break, and that one's a little bit lengthy.
No, the packets are gonna
Radicals and rational functions.
The packets are gonna be a bunch of bad work.
It's one more week. You know, one more week. Oh,
It's the first
we're
weekend.
almost done.
It's the first. It's this weekend.
I don't want to come back after spring break. I should just stay home.
First weekend April. Or first like 2 days of April.
All right. Shh, 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 shh. Any questions on any of this? Okay, so you guys got a new delta math. I expect you to be working on it. Use your time wisely. So guys, this is not the time to screw around. You literally have 40 minutes. You can easily knock out this delta math in 40 minutes.